At lower latitudes, the atmosphere can unleash relentless, overwhelming heat, followed closely by massive volumes of water. Yet travel far enough away from those tropical storms, and you find the exact opposite extreme: barren, freezing environments, where the ocean itself is locked under thick sheets of ice. To anyone standing on the ground, these wildly different climates, sudden storms, and shifting daylight hours feel totally chaotic. But this chaos is an illusion. Every extreme environment on Earth is the entirely predictable result of just 3 simple physical rules. This diagram shows our baseline physical reality. Earth is a solid, round sphere, and the sun acts as a singular, stationary flashlight. Because of that spherical shape, the sun's light can only hit exactly 1/2 of the planet at any given moment. If the planet never moved, the sun-facing side would burn in permanent daylight, while the far side would be frozen in endless pitch-black night. To prevent freezing, we add the first rule: the spin. The planet rotates on an invisible axis once every 24 hours. This rotation ensures different parts take turns facing sunlight. A town crossing the shadow experiences morning, creating the day and night cycle. But a perfectly vertical spin has a limitation. Every location on the planet would get exactly 12 hours of light and dark every day. So we add the second rule, the orbit. The spinning planet travels in a massive 365-day circle around the sun. Now we have a day and we have a year. But mathematically, we still do not have the mechanics to create a hot summer, a freezing winter, or those long summer evenings. Scientists believe that billions of years ago, a massive Mars-sized object smashed violently into the forming young Earth. Looking at our model, we see the result of that impact: the tilt. Earth was permanently knocked off balance, leaning at a 23.5-degree angle. Watch what happens during its orbit. For half the journey, the northern hemisphere physically leans toward the sun. That geometric lean directly into the light extends the daylight hours and concentrates the heat. That is summer. Leaning away 6 months later is winter. You can test these mechanics right in the middle of the planet at the equator. Because it sits exactly in the center, the tilt barely alters its exposure to the sun. These regions maintain a near-perfect balance of 12-hour days and nights all year. Contrast that with the extreme top and bottom of the planet. At the poles, Earth's curve means sunlight arrives at a low, weak angle, spreading the heat out and leaving those areas freezing. During the summer months, the 23.5-degree tilt leans the poles so far toward the sun that it cannot spin into the shadow. The sun simply hovers above the horizon for 24 hours a day. There is one notable overriding exception to this strict latitude rule: altitude. For roughly every 1,000 meters you climb upward, the air temperature drops by 6.5 degrees Celsius. That is why heavy snow clouds can form high in the Himalayas, even when the surrounding lowlands are warm. Aside from elevation, your local climate is ultimately just a measure of how directly your specific coordinates on the globe are pointed at the sun. Look at what happens to this diagram if we remove that ancient collision. What if Earth had remained perfectly straight up and down? Without the tilt, the seasonal variations we rely on would vanish. Summer, winter, spring, and autumn would instantly cease to exist. Plant evolution, animal migration patterns, and human agriculture evolved entirely around the cyclical disruption of those seasons. Without that random 23.5-degree accident billions of years ago, the biosphere would be incredibly uniform. Human civilization would look completely different. Fortunately, our planet remains beautifully off balance. When you experience a warm summer day or an early winter sunset, you are witnessing the mechanics of the solar system. Standing on the ground, you are feeling the direct consequence of a tilted rock leaning towards its star. All the intricate ecosystems, heavy monsoons, and midnight suns are the graceful output of a giant spinning ball, orbiting 150 million kilometers away.